YouTube is probably one of the apps I spend most of the time with when I'm bored and I need to seek information. And one of my biggest complaints is its search functionality, which in my opinion is quite cumbersome to use. Giving YouTube API is completely free. I thought, why not build a customized YouTube search app using Python? And by building a fully functional desktop application from ground up, you will learn the end-to-end development to get more hands-on experience with app development. Before diving into the app development, let me give you a quick demo to the app to cover the features we will be building, and as well as going over the agenda. On the screen is the YouTube search app. The first thing you see, we have all the UIs embedded on the same page, duration, and video type. On the top, we have the connect button to connect to YouTube API. Then we have a variety of filters. With the YouTube search app, you will be able to search videos, channels, and playlists by published date range, safe setting, video language. We can also set the total results to be returned. Keep in mind that most of the time up to 600 total results can be returned, and we have an instant search to filter the list by video name. To use the app, I will simply click on Connect to connect to YouTube API. In the search field, let's say I want to search Google Cloud videos between April 1st and April 5th with duration longer than 20 minutes. And I want to return videos and limit the results to 200 items. Then I will click Query to return the results. Here I can sort the table like an Excel table, move columns around, and use instant search to filter the results. Now, if you don't want to watch a video, instead, you just want to read the transcript, the app has a transcript generate button to display a video's transcript in a separate window. Finally, we can export the results to a CSV file for future use. Before we start the development, I just want to point out that the tutorial is aiming for intermediate and advanced users who have at least some hands-on experience building apps on their own. But if you are a beginner, you're more than welcome to follow along, and I am pretty sure you will learn a thing or two. I will break down the tutorial into two parts. In part 1, we will set up YouTube API and OAuth protocol in Google Cloud. And in part 2, we will start with the app development. That's everything for the agenda. Now let's dive into the tutorial. I highly recommend you create a Python virtual environment for this project to keep dependencies isolated. There are 3 Python libraries we need to install. One is PyQt6, a cross-platform desktop framework that can run on various operating systems like Windows, macOS, and Linux. One is Google Python Client SDK to connect to YouTube API, and one is YouTube Transcript API to download YouTube videos transcript. Open a terminal and type pip install Google API Python Client, Google Auth HTTPlib2, Google OAuth lib, PyQt6, and press enter to install the Python packages. Now we can move on to set up YouTube API. To start with Google APIs, navigate to console.cloud.google.com. You can skip this step if you already have a Google Cloud project and have YouTube Data API enabled. If you're a new user, create an account and it's free. On the top, click on the drop-down, click New Project. Give the project a name and click Create. Once your Google Cloud project is created, click Select Project. Now we need to enable YouTube API. On the navigation menu, navigate to APIs and Services. Click Library. Search YouTube Data API. In the search result, select YouTube Data API. Enable YouTube Data API. Once we have enabled YouTube Data API, we need to create an OAuth consent screen. The OAuth consent screen on Google Cloud configures the user consent process for apps accessing Google services, showing users what data the app wants to access and allowing them to grant or deny permissions. On the left-hand menu, click OAuth consent screen. You can also create an OAuth consent screen from APIs and Services. For the user type, select External, then click Create. For the app name, type YouTube Search App. Enter an email for user support email and developer contact information. click Save and Continue. On the Scopes page, click Save and Continue. On the Test Users, add other users who will be using this app. Then click on Save and Continue. Review the information and click Back to Dashboard. To connect to YouTube Data API, we need to create an OAuth account. Click Credentials. On the top, click Create Credentials. Select OAuth Client ID. For the application type, choose Desktop App. Give the OAuth account a name. Click Create to create an OAuth account. Click Download JSON to download the OAuth client file. Save the client file in your project folder and name the file clientsecret.json. At this point, we are done with setting up YouTube API. We can dive into the app development. To manage YouTube API, I created a Python module called Google APIs. You can download the source code and other resource files from the link in the description. Create a new Python file and name the file youtube.py. The YouTube module will be used to work with YouTube API-related operations. From datetime, import datetime and time zone. From Google API, import the create service function. Create a dictionary object called relevant languages to define the languages. Create a function called datetime to RFC with 3 parameters called year, month, and day. The datetime to RFC function is used to convert a date into RFC 3339 format to be used with YouTube Data API. Create a class called YTData. For the init method, set client file as the parameter. Inside the constructor, define the attributes for YouTube API name, API version, scopes, and client file path. Set the default service attribute to none. Create a method called initService to initialize a YouTube API instance. Inside the method, use the createService function to construct a YouTube API service instance. To perform the search, create a method called VideoSearch. This method accepts several parameters to tailor your search. Start with query, the main search term, order type, set to relevance by default, determines the sorting of results. Use search type to specify the nature of the results, with video, channel, playlist as the default. You can also define the time frame of your search with published after and published before. Relevance language filters results based on language. Adjust video duration and video type to refine the video criteria. Lastly, max items controls the maximum number of results returned, defaulting to 50. Insert an if statement to set the items to be returned per API call and name the variable items per call. Since the maximum number of items returnable per API call is 50, if the max items argument is less than 50, we adjust the number of items returned to the lesser of the two. To perform the search, from self.service.search.list, insert the arguments, then append the execute method at the end. Save the output as response. You can find more information from YouTube API's documentation, which you will find the link in the description. From the response object, retrieve the results from the items key. And if there are more items needed to be retrieved, a next page token will be available. Save the next page token in a variable. To retrieve the remaining items, insert a while loop with one condition to check if max items argument is greater or equals to item count in the items list, and another condition to check if next page token is presented. Then, use the service.search.list method with the same parameters, adding the next page token to retrieve results from the subsequent page. After retrieving all the results, return the items object. That's everything for the YouTube module. Now let's dive into YouTube widget module development. The YouTube widgets module contains custom widgets to construct the YouTube search page UI. Create a Python file called YTVideoSearchWindow. Start the script by import the sys, os, csv, and io modules. Import datetime class from the datetime module. From PyQt6.Qt widgets module, import widgets including QApplication, QWidget, QComboBox, QLabel, QTable, QDateEdit, QSlider, QPushButton, QLineEdit, QCheckbox, QButtonGroup, QStyledItemDelegate, QTabWidget, QTextEdit, QToolButton, QDialog, QHeaderView, QBoxLayout, QVBoxLayout, and QFormLayout. From PyQt6.qGuy module, import QBrush, QColor, QKeySequence, QIcon, QPixMap, QPainter, QStandardItem, QDesktop Services, and QStandardItem model. From PyQt6.qCore module, import QURL, QDate, and QSortFilter proxy model. From PyQt6.qNetwork module, import QNetwork Access Manager, QNetwork Request, and QNetwork Reply. These are used for network-related tasks such as making HTTP requests. From the YouTube module, import YT data, relevant languages, and date time to RFC. Finally, import the YouTube Transcript API class from the YouTube Transcript API module. Create a class called TranscriptionDialog with QDialog as the base class. The class is used to build and manage a dialog for displaying YouTube video transcriptions. Inside the TranscriptionDialog class, define the initialization method with parameters for the video ID, video title, and an optional parent. First, call the parent class's initializer to set up the basic dialog properties. Then resize the dialog to 800 by 600 pixels and set it as modal, meaning it will block input to other windows until it's closed. Set the window's title to video title and its icon to a YouTube icon located in the specified path. Assign the parent argument to self.parent. Create a vertical layout for the dialog by creating an instance of QVBoxLayout. Set this layout as the main layout of the dialog using setLayout method. Next, add a read-only text editor to the layout by creating an instance of QTextEdit, setting its read-only property to true, and adding it to the layout using addWidget method. If a video ID is provided, call the displayTranscript method to fetch and display the transcript. Define the displayTranscript method, which takes video ID as an argument. Inside this method, try to fetch the transcript from the YouTube Transcript API using the provided video ID. If successful, concatenate all pieces of the transcript into a single string and display it in the text editor. If there is an exception, catch it and display the error message on the parent status bar using its setText method. This helps in providing feedback on what went wrong during the process. Create a class named YTTableView, which inherits from QTableView. This class is designed to display and manage a tabular view that can handle YouTube data or similar datasets. Inside the YTTableView class, define the initialization method with an optional parent parameter. Start by calling the parent class's initializer to set up the basic table view properties. Enable sorting on the table by calling setSortingEnabled method and passing true as the argument. Allow the user to move sections of the horizontal header by calling setSectionsMovable method with true. Define a method named keyPressEvent to handle keypress events. This method takes event as a parameter, which represents the key event. Inside this method, check if the pressed key matches the standard copy key sequence using event.matches and qKeySequence.standardKeyCopy. If it is a copy event, proceed to handle the copy operation. Get the currently selected indexes in the table using self.selectionModel, selection indexes. If there are selected indexes, extract and sort the rows and columns from these indexes. Calculate the number of rows and columns that the selection spans. Initialize a table with empty strings based on the number of rows and columns calculated. Loop through each selected index, adjust its row and column based on the minimum row and column of the selection, retrieve the data from the index, and place it in the correct position in the table. Create a string IO stream and use csv.writer to write the rows of the table to the stream with commas as delimiters. Set the contents of the stream to the system clipboard. If the event does not match a copy operation, call the superclass's keyPressEvent method to handle other key events. This ensures that all non-copy key presses are handled as they would be in a typical QTableView. Create a class named DateEdit that inherits from QDateEdit. This class is specifically designed to handle date input in a user-friendly manner with a pop-up calendar. Inside the DateEdit class, define the initialization method without any parameters. Begin by calling the parent class's initializer to set up the basic DateEdit functionalities. Enable a calendar pop-up for the DateEdit by setting setCalendarPopUp method to true. This allows users to select a date using a visual calendar interface, which can be more intuitive than typing a date. Set a fixed width for the DateEdit widget by calling setFixedWidth method with a value of 100 pixels. This ensures that the widget maintains a consistent size, which is useful for layout consistency in user interfaces. Limit the maximum selectable date to the current date by calling setMaximumDate method with qdate.currentDate. This prevents users from selecting a future date, which can be useful for applications requiring a past or current date input. Create a class named ImageDelegate that inherits from QStyledItemDelegate. This class is designed to manage the display of images in a table view using URLs provided in the table's cells. In the initialization method of ImageDelegate, start by calling the parent class's initializer with an optional parent parameter to set up basic ItemDelegate functionalities. Initialize an instance of QNetworkAccessManager and assign it to self.manager. This manager handles all network requests asynchronously. Connect the finished signal from the network manager to a method named handleFinished to process the data once a network request completes. Also, initialize a dictionary named self.pixmaps to store qpixmap objects, which represent the images retrieved from URLs. Define the paint method with parameters for a painter, option, and index. In this method, check if the column of the current index is 0, which is assumed to contain thumbnail URLs. If the URL is not already in self.pixmaps, create a QNetwork request with the URL and use self.manager to initiate a GET request. If the URL is in self.pixmaps, retrieve the corresponding pixmap, scale it to fit within the cell while maintaining the aspect ratio, and calculate its centered position within the cell. Use painter.drawPixmap method to draw the image in the cell. If there is no pixmap and it's not the designated image column, call the superclass's paint method to handle default painting. Create a method called handleFinished to process finished network requests. Extract the URL from the network reply and check for any network errors. If there are no errors, read the data from the reply, create a qpixmap from it, and scale the image. Store the scaled pixmap in self.pixmaps using the URL as the key. Lastly, call deleteLater method on the reply to prevent memory leaks. Create a class named UrlItem that inherits from QStandardItem. This class is tailored to represent URL items in a table or list model, ensuring that the URL data is handled distinctly and efficiently. In the initialization method of UrlItem, start by calling the parent class's initializer with a default display text of URL. This helps in identifying the type of data the item holds in views like lists or tables. Assign the passed URL parameter to self.url. This stores the actual URL, making it accessible elsewhere in the application as needed. Set the item to be non-editable by calling setEditable method with false as the argument. This ensures that users cannot modify the URL directly in the view, maintaining data integrity. Adjust the text alignment of the item by calling setTextAlignment method and passing qtOutAlignment flag align center attribute. This centers the default text in the item's display area, enhancing the visual layout and making it easier to read and locate within a model view interface. Create a class named ButtonDelegate that inherits from QStyledItemDelegate. This class is specialized for embedding interactive buttons within certain cells of a table view, providing additional functionality like launching dialogues or handling specific data-related actions. In the initialization method of ButtonDelegate, start by calling the parent class's initializer and passing a parent widget. Also, assign the baseApp parameter to self.baseApp to store a reference to the main application or parent widget, which can be useful for accessing global properties or methods within the application. Define the paint method with parameters for a painter, option, and index. In this method, check if the current column is 3 and if no widget is already set for the index using self.parent, indexWidget, index. If no widget is set, create a QPush button with the label Show Text. Place this button in a QV box layout, adding stretches before and after the button to center it vertically within the cell. Wrap the layout in a widget and set it as the layout of the newly created widget. This setup allows the button to appear properly within the cell. Retrieve the video ID and title from the model's respective columns to use these as parameters for the button's action. Connect the button's click signal to a Lambda function that calls launch_transcription_dialog method with the current index, video ID, and video title. This setup will trigger a function designed to handle the button's action when clicked. Use self.parent. Set index widget method to set the custom widget as the content of the current cell, replacing the default text or data representation with an interactive button. Define launch transcription dialog with parameters for the index, video ID, and video title. This method is intended to handle the button's click event, instantiate a transcription dialog using the video ID and title, and execute it modally. This dialog could be responsible for displaying detailed information or performing operations related to the video ID. Handle any exceptions by displaying an error message on the application's status bar, ensuring the application remains robust and user-friendly in the event of errors. Override the createEditor method to prevent editing of the cell where the button is embedded. Return none to ensure that no editor is created for these cells, thus maintaining the cell's interactivity strictly through the embedded button and not through direct data editing. Create the YTVideoSearchWindow class, which inherits from Quidget. This class is designed to facilitate searching YouTube videos through a graphical interface. In the constructor of the YTVideoSearchWindow class, begin by calling the constructor of the base Quidget class, passing the parent as an argument. Initialize an attribute named headers with a list of strings that represent the column names for the video search results, such as thumbnail URL, video ID, channel name, playlist ID, video title, publish time, hyperlink, and transcript. Set the model attribute to none, which will later be configured to store the data model for displaying search results. Also, store the provided parent and base window parameters into the attributes self.parent and self.baseApp respectively for later use. Create a dictionary called layout within the class to manage the various layouts of the user interface. In this dictionary, add an entry named main and assign a QVBox layout object to it. Use the setLayout method on the Q widget to set this QVBox layout as the main layout. Proceed to call the initUI method to set up the rest of the user interface components. Create the initUI method to initialize the user interface within the YTVideoSearchWindow class. First, create a QStandardItemModel object and assign it to self.model. Set the horizontal header labels of self.model using the predefined headers list. Next, create a QSortFilterProxyModel object and assign it to self.proxyModel. Set the column index for filtering in self.proxyModel to 5, which corresponds to video title. Set the source model of self.proxyModel to self.model. Create a QFormLayout object and store it in the video search entry of the self.layout dictionary. Add this video search layout to the main layout stored in self.layout. Create a QPush button with the label and connect its clicked signal to the connect to YouTube method of the parent. Add this button to the video search layout. Create a QHBox layout and store it in the search row entry of the self.layout dictionary. Create a QLine edit for the video search query input, set its placeholder text to enter search query, and connect its return pressed signal to the display search results method. Set the fixed width of self.videoSearchQuery to 600 pixels. Add a Q label with the text search and self.videoSearchQuery to the search row layout with left alignment. Create a dictionary called sorting order containing various sorting criteria and their respective API parameter values. Create a QCombo box, populate it with the keys of the sorting order dictionary, and add it to the search row layout along with a label sort by. Add a stretch to the search row layout to provide spacing, and add search row layout to the video search layout. Invoke the Create Video Type checkbox method and add its resulting widget, a group of checkboxes for video type, to the video search form layout under the label Type. Create a QHBox layout for additional filter options and assign it to the combo filter key in the self.layout dictionary and add to the video search layout. Add a Q label labeled Published After and a DateEdit widget set to a date 60 days prior to today to the combo filter layout, aligning both to the left. Add a Q label labeled Published Before and a DateEdit widget set to today's date to the combo filter layout, also aligned to the left. Add a Q combo box for language selection and populate it with language options from a relevant language dictionary. Add this combo box and a Q label labeled Language to the combo filter layout. Add a Q combo box for selecting the safe search level. Populate it with options Moderate, None, Strict, and add this along with a Q label labeled Safe Search to the combo filter layout. Add a Q combo box for choosing video duration. Populate it with options Any, Short, Medium, Long, and add it along with a Q label labeled Video Duration to the combo filter layout. Add a Q combo box for selecting video type. Populate it with options Any, Episode, Movie, and add it along with a Q label labeled Video Type to the combo filter layout. Add a stretch to the end of the combo filter layout to push all components to the left. Create a QHBox layout named Slider Max Results and store it in self.layout. Create a Q slider with a horizontal orientation, set its minimum to 5, maximum to 1000, value to 50, and tick interval to 50. Create a Q label to display the current slider value and connect the slider's value changed signal to a Lambda function that updates this label's text. Set the initial text of this label to 50. Add both the slider and its value label to the Slider Max Results layout and label this section Max Results in the video search form layout. Create a QHBox layout for action buttons and assign it to Button in the self.layout dictionary. Add the button layout to the video search form layout. Create a Q push button labeled in Query and connect its clicked signal to self.display search results. Add the query button to the button layout. Creating Q line edit for instant text search, set its placeholder to instant search and connect its text change signal to self.onTextChanged. Add this instant search box to the video search form layout. Create a YTTableView for displaying video search results, set its model to self.proxyModel, and connect its double-clicked signal to self.openURL. Add the results table to the video search form layout to display the search outcomes. Create a method named onTextChanged. This method will be called whenever the text in the instant search Q-line edit changes. Start by retrieving the current text from the instant search Q-line edit using its text method and store this in a variable named searchText. Set the regular expression filter of the proxy model to the search text. This allows the table displaying the search results to dynamically filter and only show rows that match the regular expression provided, effectively updating the search results as the user types. Create the Create Video Type checkbox method to set up checkboxes for video type filtering. Start by initializing a QButtonGroup object and assign it to self.checkboxGroup. Create a dictionary named self.checkbox to store the different checkbox objects. Create 4 QCheckbox objects with labels All, Video, Channel, and Playlist. Store each checkbox in the self.checkbox dictionary under keys All, Video, Channel, and Playlist respectively. Connect the state changed signal of the all checkbox to the check all uncheck all method. This allows the all checkbox to control the state of the other checkboxes. Set the exclusivity of the self.checkbox group to false, allowing multiple checkboxes within the group to be checked simultaneously. Connect the button toggled signal of self checkbox group to the check checkbox state method. This setup enables the application to respond when any checkbox's checked state changes, allowing for dynamic updates based on user interaction. Loop through each checkbox in the self.checkbox dictionary. If the text of a checkbox is not all, add it to self.checkbox group. This excludes the all checkbox from the group to allow its special behavior. Create a QHBox layout and store it in the checkbox group key of the self.layout dictionary. Add each checkbox from the self.checkbox dictionary to this horizontal layout. This arranges all checkboxes in a single row. Add a stretch to the end of the self-layout checkbox group to push all checkboxes to the left, providing better visual spacing. Create the check all uncheck all method to manage the check state of all checkboxes based on the all checkbox. Start by iterating through each button in self.checkbox group using a loop. Inside the loop, check the state parameter. If the state equals 2, which corresponds to the checkbox being checked, set the checked state of the current button to true. If the state equals 0, indicating the checkbox is unchecked, set the checked state of the current button to false. This method ensures that toggling the all checkbox will either check or uncheck all other checkboxes in the group accordingly. Create the check checkbox state method to update the all checkbox based on the state of the other checkboxes. Begin by initializing an empty list named checkbox states. Loop through each checkbox in self.checkbox group. Append the checked state of each checkbox to the checkbox states list. After collecting the states, evaluate the collective state of the checkboxes. If all checkboxes are checked, all items in checkbox states are true, set the all checkbox state to fully checked and disable its tree state capability. If none of the checkboxes are checked, all items in checkbox states are false, set the all checkbox state to unchecked and disable its tree state capability. If some but not all checkboxes are checked, set the all checkbox state to partially checked. This indicates that not all checkboxes under the all group are uniformly checked. This method ensures that the all checkbox accurately reflects the state of the other checkboxes, providing clear visual feedback to the user about the overall selection status. Create the OpenURL method to handle the opening of URLs from a table cell. Start by checking if the column of the provided index is 7, which corresponds to the hyperlink column. If the column is correct, retrieve the item from self.model at the specified row and column of the index. Extract the URL from the item using its URL attribute. Create a QRL object with the extracted URL. Use qdesktopservices.openURL with the created QRL object to open the URL in the default web browser. This action allows the user to access the hyperlink directly from the application. Create the display search results method to handle the search and display of YouTube video results based on user-defined criteria. First, initialize an empty string search type to store the types of videos to search for. Check the state of the all checkbox. If checked, state equals qt.checkState.checked, set search type to include video, channel, and playlist. If partially checked or unchecked, iterate through each checkbox, video, channel, playlist, append video, channel, or playlist to search type if the respective checkbox is checked. If no checkboxes are checked, default search type to include all types. Trim any leading comma from search type if it starts with 1. Retrieve the maximum number of results from self.sliderMaxResults. Get the sort order from self.sortingOrder using the selected item in self.comboSorting defaulting to relevance. Convert the selected dates from self.publishedAfter and self.publishedBefore to Python date objects. Fetch the language setting from a dictionary using the selected item in self.comboRelevantLanguage. Retrieve the video duration and type settings from their respective combo boxes and convert them to lowercase. Check if the video type or duration settings require search type to be video. If video type is not any and search type does not include video, display an error message on the status bar and exit the method. Similarly, if video duration is not any and search type does not include video, display an appropriate message and exit. Verify the connection to the YouTube API. If not connected, display a connection error message on the status bar and exit. Check if a search query has been entered. If the search query is empty, prompt the user to enter a query and exit the method. Clear the existing data from self.model and reset the horizontal header labels to the predefined headers. Set the model of self.result table to self.proxy model to prepare for displaying search results. This setup is necessary before performing the actual search to ensure the table is ready to display any new data. Create a try-except block to handle potential exceptions during the video search process. Inside the try block, call the video search method on self.parent.yt to perform a search with several parameters. Use search query for the text input by the user. Set search type to specify the types of results to search for, such as video, channel, or playlist. Specify max items to limit the number of search results according to the value from self.slider_max_results. Use datetime to RFC function to convert the published after date to RFC format by extracting the year, month, and day from the selected date. Similarly, convert the published before date to RFC format using its year, month, and day. Set relevance language to filter results based on the language selected by the user. Specify video duration to filter results based on the duration of the videos. Set order type to define the sorting order of the search results, such as relevance. Finally, set video type to filter based on specific types of videos like episode or movie. In the except block, capture any exceptions as E. Print the exception details using print E. Use setText method on self.baseApp.statusBar to display the reason for the exception using *e.reason. Exit the method using return to prevent further execution in case of an error. This ensures that the application handles errors gracefully and informs the user about the issue. Create a loop to process each row of search results. Enumerate over search result to get both the row number, row num, and the data, row data. Extract various pieces of data from row data. Retrieve video ID from the nested ID and video ID. Get channel ID from the nested snippet and channel ID. Fetch title from the nested snippet and title. Obtain thumbnail URL from the nested snippet, thumbnails, default, and URL. Retrieve channel title from the nested snippet and channel title. Fetch publish time from the nested snippet and publish time. Get playlist ID from the nested ID and playlist ID. Determine the hyperlink based on the available IDs. If playlist ID is available, set hyperlink to the YouTube playlist URL using playlist ID. If video ID is available and playlist ID is not, set hyperlink to the YouTube video URL using video ID. If neither is available, set hyperlink to the YouTube channel URL using channel ID. Create instances of QStandard item for each piece of data. Video ID item for video ID, channel ID item for channel item for title, thumbnail URL item for thumbnail URL, channel title item for channel title, publish time item for publish time, playlist ID item for playlist ID, hyperlink item as an instance of URL item, with hyperlink transcript button item as a generic QStandard item. Set the foreground color of hyperlink item to blue using QBrush and QColor. Add these items to self.model at the appropriate columns for row num. Set thumbnail URL item at column 0, set video ID item at column 1, set channel ID item at column 2, set channel title item at column 3, set playlist ID item at column 4, set title item at column 5, set publish time item at column 6, Set hyperlink item at column 7. Set transcript button item at column 8. Reset the source model of self.proxy model to include the updated self model. Autofit columns in self result table for better visibility. Resize column 3 channel title and column 5 title to fit their contents. Set a button delegate for handling button interactions in column 8 of self result table. Set the vertical header of self result table to resize rows to fit contents using QHeaderView, resize mode, resize to contents. Assign an image delegate to column 0, thumbnail column of self result table to handle the display of thumbnail images. Finally, display the message online on self.baseApp.statusBar to indicate that the search and display operations are complete and online. Create the YTVideoSearchApp class, inheriting from Quidget. This class is designed for handling the user interface and functionalities of a YouTube video search application. Define the constructor method with parameters client file and parent, defaulting parent to none. In this constructor, call the constructor of the base Quidget class with parent as its parameter. Inside the constructor, assign the parent parameter to a member variable self.parent. Initialize a counter as self.counter with the initial value of 1. Set self.yt to none and store the client file parameter in self.clientFile. Create a dictionary named layout in self.layout. Add an entry main to this dictionary and assign it a QVBox layout object. Set this QVBox layout as the main layout of the widget by using the setLayout method. Call the initTabWidget method to set up the tabs in the user interface. Also, call the initUI method to initiate additional user interface setups. Retrieve the action export to CSV action from self.parent and connect its triggered signal to the export to CSV method. This sets up the functionality to export search results to a CSV file when the action is triggered. Define the export to CSV method to handle the exporting of data to a CSV file format. First, retrieve the current widget from self.tabWidget and assign it to the variable widget. Next, get the model associated with the result table in the widget by accessing widget.resulttable.model and store it in model. Insert an if statement to check if the model contains any rows. If model.rowCount returns 0, use self.parent.statusBar.setText method to display no data to export in the status bar, and then exit the method using return. Extract the search query text from widget.VideoSearchQuery using the text method and store it in search query. Generate a timestamp in the format year, month, day, hour, minute, second using datetime.now. Stref time sent y ss and assign it to the variable timestamp. Retrieve the source model from model using the source model method and store it in source model. Open a new CSV file named after the search query and timestamp with write permissions and UTF-8 encoding. Within this file, initialize a CSV writer object using csv.writer file. Write the first row of the CSV, which contains column headers. This row is created by iterating over the columns of the model and calling model.headerData for each column, specifying the horizontal orientation. Iterate through each row in the model using a for loop. Initialize an empty list row data to store the data for the current row. Inside another for loop that iterates over the columns, check if the current column index is 7. If it is, retrieve the item from the source model at the current row and column and append the URL attribute of the item to row data. For all other columns, append the data directly retrieved from model.data at the current index. After iterating through all columns, write the row data to the CSV file using writer.writeRow. After all data is written to the CSV, update the status bar with the file name indicating successful export using self.parent.statusbar.setText. Define the initTabWidget method to initialize the tab widget for the application. First, create a new QTabWidget object and assign it to self.tabWidget. Configure the tab widget to allow tabs to be closed by setting its Set Tabs Closable property to true. Connect the tab close requested signal of self-tab widget to the close tab method. This setup will trigger the close tab method whenever a tab close request is initiated by the user. Create a QTool button object and assign it to the variable button. Set a tooltip on the button with the text Add New Tab using the setTooltip method. Set an icon for the button with the path to the image using setIcon and QIcon. Connect the clicked signal of button to the Add Tab method. This connection allows the creation of a new tab each time the button is clicked. Place the button in the top right corner of the self.tab widget using the setCornerWidget method, specifying the top right corner with q.corner.toprightcorner. Finally, add self.tab widget to the main layout stored in self.layoutMain using the addWidget method. This step integrates the tab widget into the main user interface layout. Define the addTab method to handle adding new tabs to the tab widget. First, add a new tab to self.tab widget. For the content of the tab, create an instance of YTVideoSearchWindow, passing self and self.parent as parameters. Set the tab label to be a string that includes self.counter, formatted as a number prefixed by hash. Next, set the newly added tab as the active tab. This is done by calling setCurrentIndex on self.tab widget and passing it the index of the last tab, which is self.tabWidget.count-1. Increment self.counter by 1 to prepare for the next tab addition, ensuring each tab has a unique label. Define the closeTab method to manage the closing of tabs within the tab widget. Start by inserting an if statement to check if the number of tabs in self.tab widget is greater than 1. This condition ensures that there is always at least one tab open. If the condition is met, call removeTab on self.tab widget with the index parameter. This method will remove the tab at the specified index, effectively closing it. Define the initUI method to set up the initial user interface components when the application starts. Simply call the addTab method within initUI. This method adds the first tab to the user interface, initializing the tabbed area of the application with its first content window. Define the Connect to YouTube method to establish a connection to the YouTube Data API. Start by creating an instance of YTData, passing self.clientFile as an argument, and assign this instance to self.yt. Use a try block to attempt to initialize the service connection through self.yt.initService. If the initialization is successful, set the text of self.parent.statusBar to online to inform the user that the application is now connected to YouTube. In the except block, catch any exceptions that occur during the connection attempt. Convert the exception message to a string using str_e and display this message in self.parent.statusBar. This action provides feedback to the user in case of an error during the connection process. And that's everything for the YTWidgets.py module. Now let's create the app.py file to launch the GUI. Open a new Python script and name it app.py. Start by importing the required modules for the application. Import the sys and OS modules, which provide functions for interacting with the operating system and the runtime environment. Next, from the PyQt6.qtWidgets module, import various widgets needed for creating the application's graphical user interface. These widgets include QApplication for initializing the application, QWidget for creating custom widgets, QPushButton for clickable buttons, and QVBoxLayout and QHBoxLayout for vertical and horizontal box layouts. Additionally, import QMenuBar for creating menu bars, QFrame for creating frame widgets, QLabel for text labels, QSizePolicy for handling widget size policies, and QSpacerItem for adding space between widgets. Also import QStatusBar for displaying status information. From the PyQt6.qcore module, import the Qt class, which contains fundamental types and constants used throughout the Qt framework. Then, from the PyQt6.qguy module, import QIcon for setting icons on widgets and QAction for triggering actions. Finally, import custom widgets YTVideoSearchApp and TranscriptionDialog from the YTWidgets module. Insert an if statement to check if the script is the main entry point of the application. Define the variable client file and set its value to client_secret.json. Create a variable called font size and set the value to 12. The font size variable is used to set the widget font size globally. Create an instance of QApplication called app and pass cs.argv as an argument. This initializes the Qt application. Set the visual style of the application to Fusion by using the setStyle method on the app instance. The Fusion style provides a modern look across all platforms. Create an instance of app window called app window to serve as the main window of the application. Call the show method to make the window visible. Lastly, call sys.exit passing app.exec as an argument. The exec method starts the main event loop of the application and ensures that the application remains running until it is closed. The sys.exit function ensures that the application exits cleanly when the event loop is terminated. Create a class named StatusLabel that inherits from QStatusBar. This custom statusbar class will have enhanced functionality to display rich text and support external links. Start with defining the constructor method init, taking an optional parent parameter which defaults to none. Within the constructor, call the constructor of the base class QStatusBar using super init parent to ensure it is properly initialized with the provided parent widget. Create an instance of QLabel and store it in the instance variable self.label. This label will be used to display messages in the status bar. Set the text format of the label to rich text using self.label.setTextFormat method and pass Qt text format rich text. This allows the label to interpret and render HTML formatted strings. Enable the label to open external links using self.label.setOpenExternalLinks true. This setting allows any hyperlinks in the label's text to be clickable, opening the default web browser to that address. Add the label to the status bar by calling self.addWidget self.label method. Define a method setText in the StatusLabel class. The method should accept a parameter named text. Clear any previous message displayed in the status bar by calling self.clearMessage. Set the new text to the label using self.label.setTextText. This updates the label's display to show the new message, supporting rich text formatting due to the settings applied in the constructor. Create a class named AppWindow with QWidget as the base class. The class will serve as the main window for the application. In the constructor method, start by calling the constructor of the base class QWidget using super init to ensure proper initialization. Set the title of the window to YouTube Search App using the setWindowTitle method. This title will appear in the Window's title bar. Set the window icon by creating an instance of QIcon with the path to an icon file and using the setWindowIcon method to apply it. Define the initial width and height of the window as 1200 and 600 pixels respectively, and store these values in self.width and self.height. Apply the minimum size to the window using the setMinimumSize method to ensure that the window cannot be resized to dimensions smaller than these values. Initialize the main layout for the window. Create a dictionary named self.layout to store various layouts used in the application. Add a key main to the dictionary with a new instance of QVBoxLayout. This vertical layout will manage the main content area of the window. Set the main layout of the window to self.layoutMain using the setLayout method. Call the initMenu method to initialize the menu bar of the window. Add a horizontal sublayout by creating and storing a horizontal box layout QHBoxLayout under the key sublayout in the self.layout dictionary. Add this sublayout to the main layout using the self.layoutMain addLayout self.layout sublayout method. Call the initUI method to complete the setup of the user interface components within the window. Define the initMenu method within the AppWindow class to set up the menu bar for the application. Create an instance of QMenuBar and assign it to self.menu. This will serve as the container for the application's menu items. Add the menu bar to the main layout of the window using the self.layoutMain add widget self.menu method. Continue by setting up the file menu. Create a menu labeled File in the menu bar by calling self.menu.addMenuFile. Store this menu in self-file menu to add items to it later. Instantiate an action for exporting data to a CSV file using QAction, passing export to CSV as the label and self as the context to which the action belongs. Store this action in self.actionExport to CSV. Add the export action to the file menu using self.filemenu.addAction self.actionExport to CSV. Define the initUI method within the app window class to set up additional user interface components. Initialize a dictionary named self.button to store references to button widgets. Add the YouTube video search widget by inserting the YTVideoSearchApp widget into the sublayout of the main window. Pass client file as an argument for configuration purposes and self to establish the parent-child relationship in the widget hierarchy. Allocate 9 parts of the layout proportion to this widget by specifying 9 as the second argument to add widget. Set up the status bar by creating an instance of the custom StatusLabel class and storing it in self.statusBar. This customized status bar allows for rich text formatting and hyperlink functionality. Set the initial text of the status bar to offline using the setText method of StatusLabel. Add the status bar to the main layout, self.layoutMain of the window using add widget. This places the status bar at the bottom of the main vertical layout, ensuring it is visible across the entire bottom of the application window. And that completes the YouTube search application. To test the app, run the app.py script. First click Connect to connect to YouTube API. If you are connecting to YouTube API for the first time, it will prompt you to authenticate. Follow the instruction to connect to the API. Update the filters and click Query to display the results. Lastly, in the instant search field, type the keyword to filter the items. And that concludes this tutorial. I hope you found this video useful. For more tutorials, make sure to subscribe and don't forget to like the video. If you have any questions or topics you would like me to cover in future videos, please leave a comment below. Happy coding, and I'll see you in the next video.